This question, we're given a function, they want absolute max and mins. So we know how to do that. We take the derivative. Now this derivative is the quotient rule, right? Because it's two functions of x divided. So how do we do the quotient rule? Well, we take turns. So this, I'm going to make this x to the half power because that's what that is. So we do the derivative of the top first off. So that half comes down and you subtract 1 from it. Yeah, let me make that 0.5. It's a 0.5, same thing, right? So that 0.5 or that half, let's make it 0.5. That 0.5 comes down, subtract 1 from it, it's minus 0.5. So there's the derivative of the top times the bottom unchanged minus the top unchanged, x to the 0.5. I have to extend this line. Oh, times the derivative of the bottom. So then you grab the bottom and you do the derivative of the bottom because it's that their turn. What's the root of the bottom? It's just 2x, huh? The 2 just comes down to 147 to 0 over the bottom squared. All right. Right. Did you track with that? That was the quotient rule. The quotient rule is just like the product rule. They take turns. Do the derivative of the top first. There's that. Times the bottom unchanged minus the top unchanged. That's a 0.5 there, times the derivative of the bottom. The bottom just be 2x over the bottom squared. Okay, and now what do we do with that? We set that equal to 0. And really what we do, let me make it more clear. We do separately the top equal to 0 and the bottom equal to 0. Why? Because if the top, because we're looking for critical values, and critical values are when the derivative is 0 or infinity. And what if the top is 0, the derivative will be 0. If the bottom is 0, it's infinity. You know what I mean? Like if you take 3 over 0, that's infinity, right? Because the bottom goes into the top infinite. But if you put 0 in the top, like 0 over 2, that's just 0 because 2 goes into 0 0 times. So if the bottom of a fraction is 0, that's infinity because the bottom goes into the top. That's how a fraction works, right? You know, like 6 over 3 is 2 because the bottom goes into the top 2 times, right? That's what a fraction means. So if zero's in the bottom, 0 goes into 3 or any number infinite times. Whereas if zero's in the top, 2 goes into 0, bottom into top, 0 times. So anyway, long story short, if the top is 0, that's going to be derivative of 0. If the bottom is 0, that's going to be derivative of infinity. Either one we want because critical values are either the derivative is 0 or the derivative is infinity, meaning either the top is 0 or the bottom is 0. The top or I should say denominator or numerator is 0. Either one. Okay. So getting back to it, let me get rid of this scribbly stuff. So then we're going to take the top um, equal to 0. So I'm bringing here. So here's the top. So 0.5 x to the minus 0.5 times 147 plus x squared minus x to the 0.5 times 2x, and we want that equal to 0, the top equal to 0. Well. Yeah, that's ugly. Here's what you want to do. Here's you want to look at these two terms, right? Because the minuses and pluses outside of parentheses are the separators. That's how you want to look at it. And you want to say first term, second term, and what do they have in common? You want to take out whatever they have and bring down here. So factor out lowest power of whatever's in common. What do they have in common? They both have an x to a zero point 0.5 or minus 0.5. So you want to factor out the lower one, which is x to the minus 0.5. That's lower. I'm going to put a bracket. You don't have to, but just I think it just might make it easier to see it. Bracket's just a fancy print, say. Okay. What goes on the inside? Well, whatever's left over. So this is going to be 0.5, 147 plus x squared minus, right? To see that so far? Right, if I was to go, this goes to here, the x to the minus 0.5 would go back and hit this, and we'd have all this, minus Now this is going to be x to the positive 1 times 2x. Why? Because x to the minus zero point 0.5 times x to the positive. Remember when they multiply powers add. You know that, right? Like x squared times x to the third is x, well, I didn't write that wrong. X squared times x to the third is x to the fifth. Powers add, right? So x to the minus zero point 0.5 times x to the plus 1, I'm getting scribbly, minus zero point 0.5 plus 1 is positive zero point 0.5. This is a positive here, right? So that's right. And then the 2x. Okay, so what? Now you said each part equal to 0. So is that true? Um, yeah, right. Right, that's true. Yeah. So I factored that out and this is a messy problem, isn't it? All right. So I'm trying to look for an easy thing to do there. It just ain't there. All right. So I'm gonna do that inside. I'm gonna distribute that on through. So half of that is 73.5 plus 5x squared minus, this is going to be 2x squared, x times 2x. Now over, do you realize that's over x to the positive zero point 0.5 equals 0. Why? Because that's what a negative power does. It goes down to the bottom and then becomes positive, right? Negative power jump to the bottom and become positive. Okay, so now let's clean up um, the top and the bottom here. Um, Yeah. So again, anything that makes it the bottom zero. So the bottom zero, x to the point 0.5 equals 0. That's really square root of x, right, is 0. So then you second power that, x is 0. 0 squared is 0. Right, so anything that makes the bottom 0, the denominator, remember as we said, can be 0, or the top can be 0. So there's the answer that makes the bottom 0, just x is 0. What about the top? Now for the top, we've got 73.5 plus, this is 0.5x squared minus 2. So that's actually going to be minus 1.5x squared, right? Plus zero point 0.5 minus 2 is minus 1.5x squared equals 0. Jump this guy to the other side and solve for x here. Minus 73.5 divided by minus 1.5. I don't know. 73.5 over 1.5? 73.5 over 1.5? I'm hoping it's clean. 49, that's beautiful. That's a beautiful sight. 49, root it. Now don't forget, plus and minus. Whenever you put a root on both sides, my saying is roof on the house, you got to go up and down the ladder. Plus and minus 7. So, all right, so we got some answers there. Through a painful toil, we got plus and minus 7. We got 0. And you know what? I never even looked at this denominator right here equal to 0. There's no way that denominator can be 0. Can you see that? There's no way. Um, how could I prove that to you? Here, let me, there's a room over here. Because if you take 147 plus x squared, am I losing it completely? So back here, when I took the derivative, right? I did the quotient rule and I had the top and the bottom. Anything that makes the top or the bottom 0, remember we talked about that makes its critical value makes the derivative 0 or infinity. So I did the top and did a whole bunch of work on the top, and that actually ended up having a little bottom of its own, and which that came out 0. Anything that made that denominator 0 would just be 0. I did finish up the top, and that came out plus and minus 7. That was hard. And now the original denominator, well, that's super easy because if you just square root that, get rid of that 2, and you get 147 plus x squared is just 0, right? You just get rid of that 2. And then move that 147 over. X squared is minus 147, okay? And then if you square root it, you can't do that. You can't have the square root of a negative number. That's imaginary. So there's no real answers done. We're done there. So the only real answers are plus or minus 7 and 0. Now, what are we going to do with those? Well, to find the absolute max and min, we gotta make a table. That's what we always do at the end of these. Step two is you make a table. So I'm going to say, all right. So I'm going to make a table here now, and it's going to have x values and then f of x, our original function, which is this square root of x. That's an ugly function. So it's square root of x over 147 plus x squared. Square root of x over 147 plus x squared. So it's square root of x. Okay. So what am I going to put in this chart? You always put in the left edge and the right edge of your interval. What is the left edge and right edge? So we go back up, the left edge and the right edge right here. This is the left. Right. We're going from 0 to 9 all along. So from 0 to 9. So x equals 0, x equals 9. And then you put in the critical values. What did I find? I found critical values of 0, already got that one, plus and minus 7. I'm going to do the plus 7, but I'm not going to do minus 7. Minus 7 is outside of the interval, right? You know what I mean? The number line goes, left edge is 0. This is 0 and 9. Negative 7 is way over here. We're only checking between 0 and 9. So forget about that negative 7. So there's all I'm going to check is those values. Again, what did I do? What is this all about? I did all that work to find the critical values, and then I did the left edge, right edge, and the critical value that's inside between 0 and 9. Negative 7 is not between 0 and 9, so he's out. All right, I'm going to plug into that function. I'm going to go now to Desmos and plug in 0. That's obviously it's going to be 0, but I'll show it anyway. Let's go. Fraction. On the top, it's the square root of 0. On the bottom, it's 147 plus parentheses 0 squared. So that's 0. That one's easy. F equals 0. Now plug in 9. Go back and put in a 9. 9. 9. Boom. 0.01, 0.013. 0.013. And then the last one, put in 7. 7, 7. And I get 0.013. Is that the same thing? That looks exactly the same. 3. What did they say the answers were? The absolute max. Oh, they just wanted the x. Sorry, I didn't know. They just wanted the x. So 7. The max is at x equals 7. The min is 0. The max is at x equals 7. Yeah, max is at x 7. This is the max. And the min is at x equals 0. Was the 9 a little lower? I don't know. Maybe it was. Put in that, whoops. Because they didn't give the 9. It must have been, they look very similar to me. Was the 7 higher than the 9? If I go back and put in the 9, here's the 7. What if I put in the 9? Here, let me just do it again here. Put in the 9. Square root of 9 over 147 plus 9 squared. Oh, they're close. 013. Oh, the 9's higher. 013. Oh no, it's low. No, the other 0131, 0134. Yeah, right. The 7 is higher. The 7 is barely higher. 0134, 0131. Yeah, I should have done one more digit. 013. What was it? 013, and I forgot already. 013, 0131, and 0134. Yeah, that's it. 0134, 0131. So yeah, that's the max. Those were close. Okay, so recapping. This is a tough problem. How do you find the absolute max and min of a function? You take the derivative, and that was a pain, quotient rule. When you have a fraction, you got to set the top 0, the bottom 0. When I set this bottom to 0 I ended up getting negative, square root of a negative is imaginary, so there's nothing there. But the top was more difficult. I had to factor out, and then that part went to the bottom, and then made the top zero and the bottom zero, got the zero, and then I solved for x, got plus and minus 7. So I made my table left edge, right edge, and the critical value 7. I threw out the negative 7, he's outside the range. Plug into the function, there's the max, there's the min, and there we go. That's how we always do it. We find the highest value, left edge, right edge, and the critical values. There we go.